Ja, guten Tag zu unserer Veranstaltung, den SM Minerals Coating Days. Für alle, die mich nicht kennen, mein Name ist Szymon Konieczka, ich bin der Anwendungstechniker bei uns im Haus SM Minerals und ich möchte gerne die Vorstellung für den heutigen Nachmittag einleiten. Unser Vortrag ist in englischer Sprache, deswegen werde ich jetzt auch in die englische Sprache wechseln. So we have a presentation and a talk from the company Nordkalk from Mr. Matti Lamela. He will talk about the topic Nordkalk Enrich, more than a PCC, unique dispersibility for more performance, cost effectivity in color and paints. Matti is the technical specialist in the company Nordkalk, and now I want to give the word to Matti.
Thank you, Simon, and good afternoon. As Simon said, my name is Matti Lammela, and I'm application manager in R&D in Nordkalk and a technical specialist for the Nordkalk Enrich product. And what is Nordkalk Enrich? It's precipitated calcium carbonate based product. You can see it in the same picture over here. I will show you with the pointer. So here is the granulated powder of Nordkalk Enrich, and in the smaller same picture, these small round particles are the actual primary particles of Nordkalk Enrich, meaning that this is the particle size of Nordkalk Enrich, meaning it's around 50 nanometers on particle size. And what are the, let's say, the main benefits or the competitive edges of Enrich is that it has this uniform particle size and shape, which we see in this same picture. It has a really narrow particle size distribution. If we compare here this light green, which is CCC, so grinded calcium carbonate, so typical microfiller, it has quite wide particle size distribution from, let's say, from 1 to 10 micrometers. This is now D52 micrometers grinded calcium carbonate. Then we have a conventional nano PCC, which is nano-sized but is agglomerated, and then it's the particle size distribution is anyway wide, and from 1 to 10 micrometers, only minor amount of these smaller scale particles. And this we can also see from the same pictures, that here we have a same picture of a conventional CCC. The black one you see on the background is a binder, so this is in the binder matrix dispersed, same amount of calcium carbonate but on different particle size. So you can see mainly these bigger particles. Then a conventional nano PCC, there you can see the minor amount of these smaller particles, but then also main amount is in these bigger agglomerates, which we can also see in the particle size distribution. Then Nordkalk Enrich. So in all these we have the same amount of calcium carbonate. Here you can see that it's really evenly dispersed in this binder matrix, meaning that it's well dispersed also in the application, what we can see also in this particle size distribution. And what this then gives in the actual paint, so what is the value in practice? I will show you short video here before we continue the presentation.
As is commonly known, adding titanium dioxide particles on their own tends to cause pigment crowding, which leads to poor paint dispersion. When the paint dries, the pigment particles pack closer to one another, forging coarse agglomerates that impair the key attributes of the paint. Thus far, the existing titanium dioxide spacers on the market have helped to eliminate the undesired pigment crowding, but often resulting in only minor benefits. A common extender encompasses nanoparticles in addition to large particles, which provokes negative titanium dioxide agglomeration, increasing the tendency to adhere with the pigments. The coarse aggregates damage the smoothness of the paint surface, resulting in poor gloss performance. Not anymore. The Nordkalk Enrich product solves this drawback with its monodispersed ultrafine calcium carbonate-based dispersion. The ultrafine uniform quality of the particles has been tailored to replace up to 15 to 20% of the titanium dioxide requirement. Further optimization of the paint formulation enables up to 10 to 20% savings in binder. Thanks to a smaller particle size than titanium dioxide, the ultrafine enriched particles keep the pigment particles from crowding, since they tend to be carried into the free voids in the paint mixture, thus resulting in the most efficient titanium dioxide spacing effect. Superior gloss improvement is achieved when the ultrafine enriched particles evenly fill the paint surface, intensifying its light reflection. Despite only partially replacing the titanium dioxide and binders, Enrich succeeds in maintaining the desired level of hiding power. The transmitting light path reaches further into the gaps of the mixture, dimming a contrasting colored substrate. In contrast, in the presence of large extender particles, the optically coarse particles deteriorate the light scattering performance due to inefficient spacing.
So, what this then means, what we saw on the video. Here I'm going to show you some effects of Enrich on different replacement levels of titanium dioxide and binder. First, gloss, which was mentioned in this video, and I want to highlight here that even though there was mentioned that there is this gloss improvement, it means that it allows to use it also in glossy applications, but it doesn't mean that it's only for glossy applications. So it can be also used in matte applications, meaning that it can be then just if the gloss stays on the same level, or it can get higher, and then it can be fine-tuned with more coarse fillers, meaning that this won't, it's not limited only on the matte applications, but it also can be used in the gloss application. And here the gloss, typically when binder is replaced or titanium dioxide is replaced, the gloss decreases. But here actually, even with 10% of titanium dioxide replacement and 25% of binder replacement, the gloss is still on the same level of 24.6 when the starting point was 24.5. So we are still on the same level, and then starting to little bit decrease when we go on the higher replacements, meaning that here we are already going above the critical PVC of paint. And then of course the gloss starts to reduce a bit, but still we have a high level of gloss. And then the same thing with wet scrub resistance. Even with really high 15% and 37.5% replacements, we have a good wet scrub resistance. So we are still on the class 1 on wet scrub when the starting point here in the class 1, when the limit for the class 1 is 5 micrometers, we are still well below the limit of 5 micrometers in a wet scrub resistance. And good level here, 10 and 25. If we compare to here 10 and 25, we still have the gloss on the same level. And then opacity, the same thing here, starts to go little more reduced when we are here on 15 and 37.5, just to show that even with really high levels we are still quite good properties, but with this 10 and 25 we are on the same level than the reference formulation here in this. And then if we go to the comparison with some competitors, so the same properties, gloss, wet scrub, and opacity, and now comparing to some other extenders, and here the extenders meaning that not typical fillers grinded calcium carbonate, but can be PCC or some. Here we have competitor one is PCC plus titanium dioxide based extender, and then other one is nano PCC based extender. There can be some organic titanium dioxide extenders as well. Here we have now picked up two competitors, and now looking at the gloss replacement levels of titanium dioxide. Already when just replacing titanium dioxide, when on the slide before this we saw that we can also replace binder with Enrich, but here we only replace titanium dioxide, and already we see that the gloss is reduced, meaning that somehow the gloss should get on the same level back again, but it's not so easy to. It means that you have to take out cheaper fillers or some other way get the gloss up again. On the other hand, Enrich increases the gloss, meaning that you can fill it a bit more, so you can add cheaper fillers, D55 microns or D57 microns filler, meaning that it makes the formulation much cheaper. Then wet scrub resistance, not that critical weakening on the wet scrub if we look at these competitors, but anyway those are also getting weaker. We are getting closer to the limit of 5 micrometers much quicker, and now only replacing titanium dioxide. Then opacity, here let's say we are on the same level. If we look at the opacity, we are on the same level with the competitors, but as we saw, I will quickly go back to this slide we had earlier. This one, we saw here that when we also replace binder, we can reach the same opacity than with the reference. So that's something we are not able to do with these competitors, as we have the gloss decrease here, we have the wet scrub resistance getting weaker, and so we cannot somehow fix the opacity with binder replacement as we are able to do with Enrich. Then here is let's say these are commercialized references. We have a lot of more different references, but just pickups from the references we have on different kind of applications and how Enrich is used in these applications. First is interior paint gloss 7. In the reference formulation there has been 16% of titanium dioxide. Also in the Enrich version there is 16% titanium dioxide, but we have replaced all the other extenders. So our product has been cheaper than the other extenders used, now meaning these organic modifiers or nano PCC or other type of extenders. So those has been replaced, and then also some amount of binder has been replaced, and the PVC has increased from 36 to 49, and we have kept all the properties, gloss, wet scrub, and so on the same level. So meaning that this is commercialized enriched version of this interior paint. Same thing with gloss 20 paint. Now here there has been some extenders. We haven't touched on those, but we have replaced titanium dioxide from 20% to 17%, and then also replaced some amount of binder, increased the PVC, but still on the same wet scrub class, and the gloss level has stayed on the same level, and all the other properties. Then going into semi-matte exterior paint, these were interior paints, and we have most of experience from the interior paints, but still we have some exterior products that we know that are commercialized as well. Here only titanium dioxide, and there we have reduced the amount from 16 to 13, and the binder amount has been reduced from 52 to 39. So the PVC increasement here, but all the properties on the same level than in the reference. Then matte exterior paint, the same, let's say the same story here. Then flooring paint, we have also, we know that there are wood oil for exterior terraces and so on. So some of these, just an example that can be used also in these applications where more durability is needed from the product. So here titanium dioxide replacement, little bit binder reduced. Also one example here that binder can be changed in maybe in a cheaper binder or not that hard binder to get the same properties. Then matte interior paint, there the replacement seems to be quite small, but of course the titanium dioxide amount in the beginning is really low, and then we have a little bit squeezed from that also, and increase the PVC even from this 86 to 90%. So very wide range, starting from this reference product here, 14% PVC, up to this 86, and then we have increased the PVC values to 26, and here even up to 90. So meaning that it can little bit push this PVC limit, and you can get the same properties with the product. We saw this on video, but a little bit repeating that where this replaceability of titanium dioxide and binder comes. So as we have these ultrafine calcium carbonate particles, enriched particles, it can go in between the spaces. We have the titanium dioxide here, the bigger white ones, and the really small enriched particles, which can go in between the titanium dioxide particles. So it can space really well the titanium dioxide particles, keeps those separated, makes the titanium dioxide the most effective at it can be. And it's also, as it's high dispersibility, means that you can fill the matrix more, you can have higher PVC without losing the properties, without losing the gloss, without losing wet scrub resistance, and so on. So means that you can little bit push the limits with the product and get more out from titanium dioxide. Then this little bit as a teaser here, this titanium dioxide free coating with Enrich and the question mark. Can we stretch the borders of pigment volume concentration? As mentioned earlier, we can increase the PVC, we can with Enrich, and on that way the titanium dioxide amount can be reduced. And why this is interesting, it's of course that 1 million, approximately 1 million tons of titanium dioxide is used in coatings in Europe, and there is demand for more sustainable solutions, and one reason is this titanium dioxide classification as carcinogenic when it's inhaled. This should be, I think this is already ongoing classification since the beginning of October. This has been this classification for titanium dioxide. And titanium dioxide also has a really high environmental footprint. The production of titanium dioxide is impacting. It's really energy consuming production, meaning that it has a high footprint and and as the volumes are big, it has a huge impact. Then, but on the other hand, the formulating this paint without titanium dioxide is challenging. But as we saw earlier, Enrich little bit allows to push the limits of PVC. We saw that wet scrub resistance stays on a good level. Even if we reduce the amount of binder, we saw that gloss stays. We have examples that the abrasion stays on a good level. But then it comes to these question marks, but how about wet hiding, opacity versus cracking? But we have seen in our laboratory that at least some of these points can be tackled and fine-tuned. Here is one example. This is not totally fine-tuned, just the test done in Nordkalk laboratory. We have done quite many tests, but this is just a pickup from these tests where we have a wet film thickness of 150 micrometers, and the reference paint here is paint gloss 7, and then we have the titanium dioxide free paint with Enrich. And there is a wet film thickness 150 micrometers. We have an opacity of 94.2. We have decided to use this quite low thickness of film to show the differences. And here only minor difference from 94 to 93 with the titanium dioxide free coating. Both now on the wet scrub class 2. So not the wet scrub class 1. We wanted to be here, let's say, pick up here the first, the most common wet scrub class 2. Then the gloss level is actually increased in this titanium dioxide free, meaning that it could be a little bit maybe filled more if it's otherwise okay, but it's easier to make it more matte and more glossy. So this can be easily fixed. And in this reference paint, there is 16% titanium dioxide, and the opacity was 94.2, and this other one, the loss level, the titanium dioxide amount is 0, as said, titanium dioxide free, with opacity 93.2, but still on the same wet scrub class. Binder amount is reduced from 32% to 14%, meaning that the PVC value is increased a lot. So it's a totally different or new way of thinking than 24% of Nordkalk Enrich and some anti-cracking agent here, less than 1%. There we are not experts in this anti-cracking agent, so the coating manufacturers, we believe, have even better solutions than we have. But then it comes to the questions, then what compromises producer or end user is ready to make. So it's not totally same. It's of course, it's a totally new, but it's titanium dioxide free, meaning that it's doable. Then just a question: what are the compromises? And let's say, last but not least, it's an eco-friendly product, enabling the eco classification when the titanium dioxide is reduced. Also, only this partial replacement means that this enables these eco classifications. The carbon footprint is reduced. We have less than 20% of the carbon footprint that titanium dioxide has. With some efficiency projects we can even get it only 10% of the what titanium dioxide has, for example. And in some cases, the WOX can be also reduced, meaning that it's a more allergy-friendly product. And here I want to thank you for your interest, and now I'm open for the questions.
Yeah, thank you, Matti, very much for the really nice talk and the presentation. Now we open to the question, and please write down the questions in the Q&A section. Now we have one question already. I don't maybe figure it out, but how is the use for solvents or water for this enrich?
So we have more experience on water-based applications, but we know that enrich is also used in the solvent-borne applications, but I think it needs to be then tested case by case. But as the trend is towards the water-based applications, we have more experience from those applications.
Okay. And how maybe you would modify a way for customers to use enrich in their products? How to maybe go step by step, maybe just exchanging one-to-one to other PCCs, because you already said it that it's more than a PCC. How to do this? Maybe can you go step by step how to give the customer a helping hand for using it?
Yeah, well, at least I can show you. I have a guideline for using enrich, but I would start with replacing titanium dioxide.
Okay.
And binder by then let's say, of course, first adjusting water, but if the dry enrich is used, there is still have to be adjusted the water from the binder, but not other raw materials, meaning that start with titanium dioxide, maybe 5%, 10%, 15% of titanium dioxide replacement. So only titanium dioxide on the first place. Then on the second round, maybe going into the binder, we have more detailed, let's say, or example test matrix for starting the replacement. But in the first place, titanium dioxide, no, not touching in other fillers or other raw materials to see how it affects. And then on the second round, then maybe fine tuning it with if dispersing agent is needed or so on. But we have more detailed examples also if needed.
Okay. Then we have one question left. I will just go here. Have you done artificial weathering when increasing the PVC of facade paints? So paint, sorry.
When increasing the PVC, you
Yeah.
said that, yeah.
Have you done artificial
by ourselves, we haven't done artificial weathering, but our customers have done, and based on those tests, at least in those applications, it has worked well, even with the higher PVC. But I don't have the detailed, let's say, results from those tests. We only know that that it is in use in this kind of facade paints, and the results has been good. But that's where we don't have the testing possibility on our own lab, so we don't have the actual results. But
okay, but you have the feedback of your customers.
Yeah, we have the feedback from the customers that it has worked.
Okay.
Yeah.
So Matti, we have now no open questions left. If there are any question from your side, so please send us the questions. We will direct it to Nordkalk, of course, if there is the need, and we will, of course, go on. But now another question comes in. When I'm talking about, maybe we can do this if it's okay for you.
Yeah, it's okay for me.
What is the oil absorption number of Enrich C, maybe?
Okay, oil absorption number. It's about 70.
70. Okay.
70 grams. Yeah.
So okay, but now we were on the finish line. Let's say I would like to thank you again, Matti, for the nice talk and the great presentation of a very interesting product. And yes, I thank you for all attendance, for being here, and I hope we can give you an appetizer for this product. And we wait for your for your ask for sampling material, of course, if there is a need. That should be no problem for everyone. Okay, so thank you all, and we will now shut down this live happening, let's say, and yes. We will go on with our next talk and presentation at 15 o'clock. Okay.
Thank you.